Hi everyone, my name is Rob Canzaneri. I'd like to welcome you all to the Data Architecture Virtual Chapter meeting for September. I have Jamey today. He's going to be talking about coding like a pirate, intro to R. I want to thank Kenny Neal. He's my co-leader. And if you ever have a question, you can email me at rob@sqltigers.com. So, upcoming meetings, we have Tim coming on and Kimberly and Kevin. So, if you'd like to talk or know a good session, email me and I'll ask some people to come on and give a session. We want to thank our sponsor, Nutanix. Because of them, we'll be giving a $100 gift card away today. Keep an eye on your spam or your junk mail. You may get an email from me, our Data Architecture Virtual Chapter, saying you're the winner of a $100 gift card. So just keep your eyes open. Kenny usually goes in there and randomly picks a person, and we give away. We're lucky enough to give it away thanks to Nutanix. And check out their website. They're our great sponsors. It's the web links right there if you have some time. So, PASS now has the elections going on. So just keep an eye out and you'll get to see who's running. It starts on the 13th, which is really soon. So if you get to go to PASS, or you're planning on going to PASS Summit event, please use this coupon. It's coupon code. You'll save $150, and on top of that, if we get enough people to use this code, I think it was 20 people, which we do have quite a few. I'm not sure if we have 20 yet. I'll have a special webinar, and we'll give away a free session to PASS. So one of y'all can go for free, which is pretty amazing. So I encourage everyone to use the code, and hopefully we'll get enough people or participation using the code that I can give a free session away to one of y'all. So upcoming virtual chapter meetings. So you can see there's a bunch here. Let's see. There's database administration and developers and fundamentals. And if you're interested in attending one of these sessions, just go to SQL Pass and sign up. And they're all free. They don't charge anything. It's pretty cool. Here's a few more. And we'll go on. And there are a lot of virtual chapters out there. PASS does support. And this is just kind of a big picture of all the virtual chapters out there right now. So upcoming SQL Saturdays. So as you can see, there's a bunch of upcoming SQL Saturdays all over the world. San Diego would be kind of nice to visit, I'm sure. But or Boston or Pittsburgh, all these great places. So if you have a chance, you go to SQLSaturday.com and register, and you can go to a free SQL Saturday. And that's the end of me. So I'm going to turn it over to Jamey now. Hold on, let's get this going. Jamey.
Yes, can you hear me?
I'm making you the presenter now. Oh, one other thing I forgot to mention. This session is recorded. I will put the links on our website. And I'd like to really thank Jamey. He's in Houston. He's okay. I asked him earlier. He made it through the hurricane okay, but he still made it to here today. So thank you, Jamey, for coming. Even though a hurricane hit you just recently.
Oh, no worries. My pleasure. Can you hear me okay?
I hear you fine.
All right, and not hearing my background noise.
Let's see if anybody's saying anything, but I don't see anybody saying they can't hear, so I guess we're good to go.
All right, let's get started. Well, thank everybody for making it out there. For those of you who are in the Houston area, like I am, in Texas or Florida or South Carolina, or Georgia, kind of all in the same boat. So we're praying and thinking for everyone, and thank you for joining, all the rest of you, and looking forward to presenting Code Like a Pirate, Intro to R, and Microsoft Data Science tools to you. Like I said, my name is Jamey Johnston. I'm a data scientist. I work for an oil and gas company here in Houston. There's a little bit about me there. One thing that I want to point out there is if you go to my blog right here, at stackcowboy.com. There's a link out there. I've put in this talk several times now, including at Summit last year in 2016. I have a link out there so you can download this PowerPoint, all the R code and SQL code and Power BI file, everything I show you in this talk. You can download it right there on my blog. There's my Twitter handle there if you want to follow me on Twitter. And then also LinkedIn right there as well. So that is what I wanted to point out there for you. So if you want to just take a screenshot of that, that'll be great. And then I think I can send that out as well after this to everyone. So here's the agenda. So it's definitely an intro to R. So it's more about the R language. The majority of what we're talking about is R itself, a basic introduction to R for, assuming that you might have some coding background, but probably, the assumption is you don't really have much of coding.
Hey, Jamey?
Yes.
You're kind of cutting out all of a sudden, like you're coming in and out. I'm not sure what could be causing that.
So just in case people missed it, my blog right here, there's the link to this session, all the code and the PowerPoint and all that at stackcowboy.com, and there's my Twitter handle. Is that good? Can you hear me fine now?
It's kind of cut in and out. I don't know why. It's kind of weird.
All right. So agenda is introduction to R. So the idea being you may have some coding experience, but probably none in R. Majority of what I'm going to talk about is R itself, where to get R, why to use R, some of the basics about R, different object types in R, packages, control flows, and then at the end, just a brief overview of where Microsoft has invested in their products with R, and then a little part with the regression demo. We won't have that time to do that, unfortunately, because we only have an hour, but the code is out there if you want to download it, and it's pretty well documented and commented so you can kind of see what it looks like. So, and then I'll have some resources for you to continue your journey in R. So that's the agenda. So why R? R is free. That's one good reason. I'll pay for it. It does have pretty good graphics and data visualization. I do kind of caveat, I tend to use Power BI, Spotfire, and another tool called SAS Jump for a lot of my visualizations when I'm doing stuff in my data. So why R? So R is free. It has some good graphics and data visualizations. But like I said earlier, if you heard me, I tend to use Power BI or another tool called Spotfire or another tool called SAS Jump for a lot of my visualizations. But there is good graphics and data visualization packages in R too. It's a very flexible statistical analysis toolkit. You have thousands of contributors contributing tons of packages and enhancements to our language to make it very powerful. And like I said, there's a very powerful open source community. And then if you work in the Microsoft stack, which probably most of you, if not all of you do, if you're in this session, Microsoft bought a company called Revolution Analytics about 2 years ago. And they've heavily invested, taken that investment with Revolution Analytics and investing that in their tools. And we'll talk a little bit at the end, with like Power BI and Azure Machine Learning and SQL Server, what they're doing around that. So just a quick check. Can you hear me better?
I'm off mute now. Yeah, I can hear you a lot better. It's working.
All right. Cool. All right, we'll keep it that way. All right, perfect. Real quick, so how do you get R? So if you've never worked with R, I'm assuming most of you are not. That's why you're on the session. If you go to rproject.org right there, you can download the latest R software, which has the R language itself. That's where I would start. And then as soon as you download that, I tend to do all my coding in RStudio. It's a free IDE. You can get that from rstudio.com. If you look to the right, here's kind of a screenshot of what that looks like. For those of you who are more familiar with Visual Studio and you want to experience that's Visual Studio-like for R, Microsoft have the R tools for Visual Studio. There's a link there to go and download the R tools for Visual Studio. And you can actually write your R code in Visual Studio. And then finally, what I have there is a link to the Microsoft R client. So one of the things, if you remember my last slide, I talked about Microsoft invested in Revolution Analytics and bought that company and brought a lot of their code. And for those of you who don't know about Revolution Analytics, which I'm assuming most of you, they're kind of a commercial variant based on R. So they write a lot of enhancements and software to R to make it faster and easier to use, to do like parallel scaling and things like that. And so Microsoft bought them to take that technology and to embed it into the Microsoft tools. And so one of the things you can do is download the Microsoft R client, which will then and connect to like Microsoft R services and SQL Server easier from your R code, or to connect and get the Microsoft to the Microsoft R server and use that, and then also have the enhanced packages that go along with the Microsoft R. So that's a link there for it. Like I said, start here with the R project, get R. Like I said, I use RStudio for my IDE. The R tools for Visual Studio is really good too if you like Visual Studios. And then if you are working the Microsoft stack, you can get this Microsoft R client and start using that. And I'll show you a little demo at the end on the R client. What is RStudio? How does it work? It's kind of broken up into 4 areas here. I'll show you it in action here in a minute. But you have this editor at the top left. This is where you can write your code. And you can run your code down here in the console. You can add your code up in the editor, execute it, and you'll see it actually executed down here in the console. On the top right, you kind of have you have this workspace here, which gives you your environment as you're creating objects and things inside of R here. You'll see them show up over here in the workspace, so you can see kind of what's going on. So it will help a lot when you're kind of debugging. You know, why am I not seeing data there? And you can look over here and see in your objects what's going on there. And then down in the bottom right, you kind of have this area I call plots, etc. So it has like any kind of graphic outputs. If you're running them in RStudio, they'll show up down here in plots. If you're working in files in a project in RStudio, there's a little thing here that says files, packages. So we'll talk about packages in a minute, but you know, you can to the base R, you can add lots of extra packages, and you will as you start using R. You can manage these packages right here, and then there's a help as well. So if you want to get help in R and a little viewer. So when you're working with R, the run options are, so if you have code here in the editor and you want to run that code in the editor, the 2 that I use the most are Control Enter, so that's going to run one line at a time. So if your cursor is on this line here and I hit Control Enter, it'll execute that one down here in the console. And the other one that I use a lot is Control Alt R. So if I have a bunch of code in this editor, I want to run all of it, I can do Control Alt R, and that will run all the code in that editor. And then here at this little screenshot up here, you can see some of your other options. So like here's the run all, Control R. Here's the run selected line, like I showed you, Control Enter. But some of the other ones that I use are the top 2 here. So like if I got my cursor right here and I want to run from the beginning of my script to where my cursor is, I can do Control Alt B. And then if I want to like run from my cursor to the end, Control Alt E. And those are the ones that I mainly use to execute code. And I'll show you a demo of RStudio and R in a minute. There's also good help built in. So you have the RStudio docs. These cheat sheets right here are very good. So when you get RStudio installed, go to help, cheat sheets, and they have some cheat sheets on RStudio, some cheat sheets on R, like data wrangling, using some of the packages that are a guy named Hadley Wickham mostly created, called dplyr and tidyr, which are really good for managing data inside of R. But there's real good cheat sheets there. And then there's also version control. So if you use tools like Git, there is version control built into support into RStudio. It's not the best. It can be slow at times, but it is there. I do use it. And then you have the ability to create like projects. So you can create a project, have multiple files, and use that in RStudio. Debugging. We won't go much into debugging, but I wanted to put some slides out there for those of you that are coders and developers. RStudio does provide debugging, so you can do breakpoints and our functions do things like browsers and debug once, and then there's trace back and stuff like that. So debugging is built into the tool. that's kind of a whole other session. I actually attended a session that was just on debugging that was like an hour and a half long. But I did want to put a couple slides.
Hey, Jamey, it's kind of cutting loose again. Did you do anything different, maybe, or no?
Is it better now?
I guess keep talking, and I'll let you know.
Yeah, sorry.
That's all right.
Maybe I moved back a little. I apologize.
Oh, no problem.
Yeah, these are sometimes hard to do. RStudio Debugging, like I said, it's built in. We're not going to go into it or show demos of it, but I wanted to put some slides out there for you. Like in the console, if you want to step into functions and finish functions and continue running, those are the shortcuts for that. So let's get into it. So kind of just to set the kind of agenda, I'm going to go through some PowerPoint for like the first 25 minutes, just to kind of level set R and what object types are in R and the basics of R. And then I'm going to go in, the last part will be pretty much all demo. So you can see how it works. I've done this session probably 10, 15 times now, and that format seems to be working best. So for those of you who like demos, we'll get to them, but this format seems to work the best to kind of level set what's going on. So basics, comments. All R has for comments is a hash, the £, the hash tag right there. So if you want to comment multiple lines, you have to put multiple pounds. The good news, if you're in like RStudio, you can highlight like 6 lines. Let's say you wanted to.
Muted. Unmuted.
Yeah.
Yeah, I can hear you now.
Yeah, for some reason it said I was muted up there on the top right. So comments, like I said, if you have multiple lines you want to comment, you have to put a £, in front of them. There's no like block comment, like a /*/ that you'd use, like say in other languages. But the good news is Control-Shift-C in RStudio, if you highlight multiple lines, will comment out multiple lines. So variable creation in R, it's a little different. So I'm going to create a little, like in this example right here, I'm showing you got M, I'm setting it equal to 3 times 5, and then if I just type the variable M, you can see that object is equal to 15 there. So notice it's not an equal sign. That is how the R language was initially. You use this <= dash. They've now added support where you can use equal, and I say that because most of the code you download, you'll see this like <= sign, but you will still start seeing a lot of other code that people write. You'll see the equal sign just because they're used to using equal, especially if they do write a lot in Python as well. A lot of people who use R also write a lot in Python, and so you'll see like M equals 3 times 5, and that'll work as well. But historically, R was the creators of R did not want to use. They didn't use an equal. They used this <= dash as equal. That's kind of the first weird thing about R that you'll see. So help is kind of built in. So if you're in the console, you can say help, and then like say for example, LM is the linear model function. If you type that, you'll get help will show up in the console in RStudio. In the etc. little window on the right, RStudio. Also, you can use this question mark and type, say, like LM, just an example, and it'll give you help on that. That's kind of the basics there. This is kind of the main meat that I want to go over in the slides until we get into demos. It's the different object types in R. So, like everything on R is an object. Typical data in R is stored in one of 4 types of objects, vectors. And so I kind of broke it down, like if you're a DBA or a developer working in databases. Vectors, you can think of them as one row with the same data type. It can be one row with like one column, or it can be one row with multiple columns. But a vector is one row of data with the same data type. And we'll go more in this in a second, the next slides. Matrices are multiple rows of the same data type. So you have multiple rows and multiple columns, but they're all going to be the same data type, whether numeric or a character. And then data frames, these are like tables. They can have multiple rows, multiple data types in them, and they work mostly a lot like tables. And in R, as you start working with data stuff, data frames is where you'll spend a lot of your time. A lot of your data will be in data frames. And finally, the last object type you have is a list, and they're a collection of objects. So a list can be made up of more. A list can be a bunch of vectors. A list can be a bunch of matrices. A list can be a bunch of data frames. A list can be a combination of a vector, a matrix, a data frame. A list can actually have list inside of list, but they're just a way to collect objects in R and list. So the building blocks for data objects in R. One thing to note, unlike other programming languages, that your indexes, like when you look at an index of something that starts at 0, R, it starts at 1. So this is position 1. And like, so this vector here, I'm using what's called the combine function to create a vector and create a V, and I'm combining it. I'm using this combine function. This vector will have the values 2, 3, 1.5, 3.1, and 4. This is position 1, position 2, position 3, position 4, position 5. Whereas in other languages, they'll start 0, 1, 2. And I'll show you a little demo of that here in a second. The seq function generates numeric sequences. So I'm going to create a variable called s, and the sequence is going to be from 0 to 100 by 0.1. Vectors, the rep function replicates values. So in this case, variable r, I'm going to create a rep, and it's going to replicate 1, 4, 4 times. So you get 1, 4, 1, 4, 1, 4. So colon will create a number sequence incremented by 1 or negative 1. So in this case, I create a variable called colon, and I'm incrementing from 1 to 10. So you'll get 1, 2, 3, 4, all the way to 10. If you wanted to go backwards, if you said like 10 colon 1, it'd be 10, 9, 8, 7, 6, 5, 4, so on. An important function to know is this length function. So I created this vector called colon 1 through 10. So there's 10 numbers in here. So the length, if I did length of colon, it would return 10. So, matrices, the matrix function is used to build matrices. And then there's also these rbind and cbind. So you can think of rbind as like union. If you're dealing, you're familiar with SQL, you can think of it like union all. Or if I had 2 matrices and I wanted to combine those 2 matrices together, I can use rbind to do that. And then cbind, you can think of it like a join, or I can take matrices and join them together based upon the columns. And then if you want a little more information about matrix algebra and stuff, there's a little link here. And I'll show you a demo of these vectors, the matrices stuff I'm talking about. I'll show you a demo. I want to kind of get you an idea of what some of the functions are that you can use. Data frames. So it's like a table. Row names are used to extract row labels. So one of the weird things about R is you can actually have labels for your rows. The labels aren't actually like a column in the data frame. They're actually labels for the rows in that data frame. So they don't show up as a column in the data frame. They are actually a row. They're actually labels for the rows. I'll show you that in a second here. And column names, you can think of these like your column headers here, or your column names for the data frame. And this function, column names, will return what those column labels are. And then you have a function called names. And what this does is it allows you to set the names of your column headers. So if you read in data into a data frame, you didn't like what the column headers or the column labels were, you can use this names function to change them. And then here I have just a few examples, there's not all of them, of just different ways in R to create data frames. So read.table, this will allow you to manually create a data frame where you tell it the name of the columns, you tell it what the data is for the columns, and it creates it. Read.csv is exactly what it sounds like. It will read a CSV file, create a data frame. Read Excel, exactly what it looks like. It's to read Excel files. And then RODBC is exactly what it sounds like, which is if you want to use ODBC connections to read data in, RODBC can do that. And there's lots of other ways to create data frames, but these are just some common ones that you'll see. And finally, list. They combine multiple, like I said, they combine multiple object types into one object. They can be made up of any of these things: vectors, matrices, data frames, lists, functions. I have a demo here later where I use lists to take and split data frames up by a different category of each data in a data frame, and I can use a list to create multiple versions of that data frame into what's called a list. We have multiple data frames in one list, and then we can in R we can do special functions called lapply that says go to that list, apply this function to each object in that list, And so you can do things really fast that way in R, so that you don't have to do like a loop through to make changes to it. You can actually have R kind of optimize to do that. And I'll show you a demo of that later. Missing data, we're all familiar with nulls and SQL Server or Oracle, whatever database you use. In R, we use they use NA to represent missing data. And you have some functions around R to work with the NA or missing data. You have the is NA, so it's going to look for where the data is missing, and you can combine that with the which function to look at NA. So it's better just to show you an example. So here, remember the combine function for the vector, creating this x, I'm putting 1, 3, 2.3, 3.4 in NA. So if you print x, you can see 1.3, 2.3, 3.4 in NA. This little bracket 1, this is just showing you that this is starting at position 1, which is this here. If you had lots of, like if I had like 100 values in this vector, it's going to look at your screen size and it'll print as much as it can on one line, and then it'll start the next line, and you'd see another bracket here, and it would tell you at what position that line was starting with. So you kind of have an idea of how big that vector is. But that's what that little bracket 1 bracket is there. So I have this x vector with one value in A. So if I want to return the location of the values that are in A, I can use the switch function and say is in A.x. I'm going to set that to n, and I'm going to use v, and then I can do the exact same thing, but this time I'm going to negate the is in A function. So what that does is going to give me all the values that are not in A, right? And so when I do this n and I print n, I get 4. And that's because position 4 is in A. And if I print v, I get 1, 2, 3. That's because positions 1, 2, and 3 are not in A. And then if you actually want to create a new vector of the data not in A, here's a little example of doing that. So I'm create this vector called y. I use that x vector that I previously set before, and I can say not is in A x. And then what it does is with this x bracket, this is taking this x vector and it's grabbing all the positions in this x vector that are not in A and getting the values. That's what these little brackets do. And so then I actually get the values here of 1.3, 2.3, and 3.4. That's how you do it missing data. The packages, they're add-ons for R. So when you install the base R, like from the rproject.org, it's going to come with some base packages like stats and maths and different things like that. But you're going to find that you're going to go and install a lot of packages as you start using R. These are here, and so some commands that are helpful. If you type the library command in the console, it'll list all the packages that are already installed in the environment. If you want to install packages at the console, you can say install.package, and then you can by comma separated list the package names that you want to install, and we'll install them. And then when you actually, after you install the package, if you want to actually load that package to be used in your R code, you're going to type library, open parentheses, the name of the package you want to use, close parentheses. And that will load that package into your R environment so that you can use it. And I'll show you in a minute when we go to demos in RStudio where you can actually manage the packages a lot and install the packages a lot easier in the environment just using RStudio. So conditional operators, every programming language has them. So I'm in R, the way that kind of looks, create a variable called x equal to 2, and then I want to say is x greater than 1. That's true, right? And then I'm going to create a vector with values 1 through 10 here, and I want to return where it's equal to 2. So let's see which one's equal to 2. So I have 1, 2, that's true, and then 3, 4, 5. So you can see when you're dealing with vectors, this equal is going to look at each value in that vector and then return back which one is true. That's equal. And then if you have the not equal, it's the opposite of that. So which one is not equal to 1, 3, 4, and so on. So that's some comparison. And then just these are some more examples. I'll show you this. Greater than equal, less than equal. So logical operations. So create a vector x equal to 1 through 4. So you can see right here when I print it out 1, 2, 3, 4. So the OR condition with this pipe here. So either x is greater than 2 or x is less than or equal to 3. Well, that's all true. So it's all either greater than 2. So 3 and 4 is greater than 2. Or x is less than or equal to 3. Well, that's 3, 2, 1, right? And that's both conditions have to be true. So x is either going to be greater than 2. So that's 3 and 4. But x also has to be less than or equal to 3. So that's only 3. 3 is the only one that's greater than 2, but also less than or equal to 3. So that's how you can do ORs. This is how you can do ANDs in R. You also have exclusive OR, where either one of the conditions has to be true, but not both. Either x has got to be either greater than 2 or x has got to be less than 4. It can't be both. So only 3 is greater than 2, but also less than. But also, 3 is the only one that's greater than 2, but also less than 4. That's why this one's false. 3 matches both conditions. So an exclusive OR, it has to match either one of the conditions, but not both. So 1 and 2 are less than 4, and they're also greater than 2. But they're less than 4, but they're not greater than 2. So that's why those are true. And then 4 is greater than 2, but it's not less than 4. So that's exclusive OR. And then a really cool function in R you'll find yourself using a lot is this percent and percent. And so if you remember when I created x, I created it 1 through 4. So I'm now creating another vector 0 through 5, and I'm saying percent in x. Well, 0 is not in 1, 2, 3, 4, so that's false. Then you have your 1, your 2, your 3, your 4. And your 5 here is false because it's not in x. And remember, x is 1, 2, 3, 4. So that's logical operations. Control flows, like if-else, so like for programming languages, R obviously has if-else. If x is less than 3, print true, else print false. We also have this little shortcut way where you can say if-else. And so you can say if-else, here's your condition. So these two lines are the same. The only difference is I kind of did this shortcut there. One thing I don't show here, but you can say if x is less than 3, you can put a little squiggly here, have several lines, put a close squiggly, and then else, open squiggly, have several lines and a close. And then you can nest if-else statements as well. I need to update this slide and add that. For loops. So we have for loops in R for I and 1 through 10, print 1, and then I. Also for the data frame, remember data frames are like tables. This little function in row returns the number of rows in that data frame. So I can loop through a data frame and print each row in that data frame. And I'll show you some demos of this will make more sense. You also have break and next and continue in your for loops. Like I said, right now I'm just trying to show you in the slides what they look like, and then we'll go into demos and we'll see them. They'll make a little more sense. They also have while loops. So I create a variable called I equal to 1. While I is less than or equal to 10, I can print I, and then I have to increment I plus 1. So let's get to the demos. So this code is out like on stackcowboy.com. You can see it right here. There's the link there. You can go and download this code, this presentation, and everything. So just real quick, here's the RStudio interface. I told you there's areas. This is the code I'm going to run. So if I want to run each line, with this line, I hit Control Enter. This statement here, all it's doing is removing all the objects in my current parsing. Just give me a clean slate. In this next session, this is just to turn off any warnings. I don't necessarily recommend in your R code, for demo purposes, so that I don't get a bunch of warning messages popping up. So here's the editor. As you can see, as I execute stuff, it executes down in the console. Here's the environment here. So real quick, if I create this vector M, 3 times 5, I get a vector, and it's got one value. You see how that shows up here in this global environment. And you also have this history tab, so you can see the history of stuff I've done. So I was doing some tests before I started the session. You can see the history there. So if you kind of want to look back at what you're doing, you can click the history. And then finally, in this etc. here, I have this as a project. So when you download, you see a project, and I can see some of the files I have in this project. The main one you really want to look at is this intro to R. And I just noticed I've done this like 10 times. I have yet to notice I forgot a R there. That's into to R. That's crazy. No one else has ever noticed that. But in this session, I did some plots earlier. You can see a plot down there. And kind of the cool stuff I want to show you, like the help. So if you want to go get help, there's some basic stuff here, but you can also search for help here. And then one thing here is, remember I was talking about packages earlier, and you want to manage packages. Here, this shows me all the packages I have installed in my environment. If I want to install new ones, I just click install there, type the name of the package I want to install, and I hit install. It'll go and install it, and specify what. I'll go and read all your packages and see if any of them need updating. If they do, there are little checkbox where you can checkbox. Click the checkbox. This is the easiest way to manage packages. This is generally how I manage them. I'm generally not going to the command prompt, all packages and typing a package down here. I'm just using the manager here. So let's just walk through some of the examples. I'm just going to kind of walk through a little bit of what I showed you in the slides. So real quick, I want to create a vector called v using the combine function. When you look up here, you can see there's that vector, 2, 3, 1, 5. And if I type v, there it is. If I want to return position 1 of the vector, I can say v1. Return position 3, I can say like v3. And you can see how I'm returning a particular portion. Sequence, if I want to create a sequence of numbers, you can see there, I just created a sequence and you can see it's 0 through 100 by 0.1. You end up with 1001 objects. Repeat, 141414, colon. So here I did print colon. You notice it does the same thing if I did R. So if I just type colon here, it does the same thing as if I did print colon. So when you just type an object, it just kind of calls its print function to return what's in that object. But I just wanted to kind of show you, if you see that, they're really the same thing. Length vector, length is 10, right? That way, and that function is useful. Like, so if you wanted to like loop through a vector of values, you can return that length to know what that is. If you want to sort, I didn't have a slide for that, but I can create a vector. You can see that it's 0 through 10, but I didn't do it in sorted order. If I want to sort it, I can create. In this case, I'm just going to create an S2 new vector, and I'm going to say sort S. And there's that vector sorted. Matrices. I created one matrices called M1 with the number 1 in it. Number of rows is 4. Number of columns is 4. I created second matrices with the number 2 repeated in it, 4 and 4. And then you can see where I print those out. If I want to combine it by rows with rbind, now you can see I've rbind M1, M2. And if you want to C-bind them, you can see where you can put the columns together. So it's kind of like a join, right? Important things to note, if you're going to R-bind stuff, you got to make sure you have the same number of columns. If you're going to C-bind something, you got to make sure they have the same number of rows, which is why up here I obviously made them the same number of rows and columns. In matrix algebra people, you want to do like products of two matrices and things like that, you can do that here. We won't go into why you would do that, but just wanted to show that can be done. So one question I get sometimes is like, where do we use matrices a lot? If you think like images, when we do deep learning and we're trying to do neural nets and deep learning to look at images and try to detect what's in the image, a lot of times you create matrices of the values of each pixel. We do the same thing in Python with NumPy, with arrays. You do kind of Python. But, that's one way I use matrices in data science. But the main object type that I use are vectors, and the biggest one I use is a data frame. So in this case, I'm just create a data frame. I hope everybody can see my screen. Okay, I just realized that. I'm going to create a data frame using this read table. Header equals true, which means I've got column labels right here. And then there's this thing called strings as factors. And what I'm saying is don't create these names as factors. I mean, they're like categorical variables. So like, example of categorical variable would be like male or female. Another categorical variable would be like you're in the Olympics and you want a gold. In these cases, these are names. So these aren't categories, they're unique. And so that's what factors does. It says don't create them as factors, which is a type of object. I mean, it's a type of, it's the way instead of numeric string, it says, hey, here's a factor. By putting that, it doesn't create it that way. And so now when I ran this data frame here, you can see where I now have this data frame up right here in this environment. And it tells me there's 11 observations with 3 variables. If I expand this little sign here, you can see I have the ID, and here's the ID values right here. I have the name, and it's type character. And you can see it's Jamie, Melanie, and some names there, and then some salaries. If you want to see what that class is, you can see the class frame. If you want to view that data frame, if you type view, the name of the data frame, RStudio will open it up right here for you, really nice, and see the contents of that. Before you got like 100 data frames, you might not want to take view data frame. You won't be able to see it. It'll take forever to open it. You also click it right here in the environment window right here, and it'll open up. Remember column names? I said, hey, this will show you the names of the columns. Remember I had headers, ID, name, salary. That's what you get there. Row names. So in this case, I didn't actually give row names to my data frame. So since I didn't give row names, it just defaulted to 1 through however many rows I had. And then if you want to get the number of rows in your data frame, you use nRow. If you want to get the number of columns, use nCol. Just for a real quick example, if you want to see, like, so R has built-in data sets that you can play with. One of them is called MT cars. So I just typed MT cars to show you that data set. And when it returned it out, you see right here, these headers here. Notice how there's not a column header here. That's because these are the row names. So if I type row names MT cars, you can see those are the row names. So that was kind of one of the weird things that when I started working with data frames in R, this concept of row names I'd never seen before. So data frames, if you want to reference like a column in a data frame by name, you can say the object for data frame, open parentheses, the name of that column. If you remember in call names, data frame, you can see ID name Sal. So by doing this one, I get the contents of that column. You want to like change the contents, like you can also reference a column by like name of the data frame, $, the name of that column. So in this case, I'm going to multiply everybody's salary by 5%. If I view that data frame, we all got a 5% raise. And you know who these are? That's me. That's my wife. You go do a demo, and your wife's included in there. Make sure she's making the most money. So, that's the lesson I learned. So accessing data frames, you want to access it by row. So these bracket, comma, bracket syntax here. It's row, then column. So in this case, I'm going to get row 1. So F1, comma, and then nothing, just row 1. And this syntax here, I got row 1, cell, or column 3. So this is just going to return that one cell. And if I just want to return one column, I can do 2. And if you notice, this is the same as doing this, right? This is just referencing it by name. This is referencing it by the column position. The other thing that's similar, if I just type this, there's the third way you can reference a column in a data frame. So list, I'm going to create a list object called li. remember the two matrix I created earlier? I created a vector called colon, and I created that data frame df. Now I have that list. If I print it out, you can see the contents of that list. Too fast. So there's print right there. There's the first one. It's the matrix 1. Matrix 2 is the second one. The third one, you can see right here, is my vector, that colon vector. And then the fourth object in that list is that data frame. And then you can use these double bracket syntax. So if I want to reference object 2 in that list, which is matrix 2 right here, I can use this double bracket syntax. And then the other thing I can do is if I want to reference an object in that list, but then after, once I get the object in the list, I can then pull a one of the values out. Since the data frame is object 4, if I say list, the li in this case is name my list, object 4, and if I say 1 comma, I'm going to pull the first row in that data frame. This is how you reference and pull objects or pieces of the objects in those lists. This is just like a linear model here where I did this. And the only thing I wanted to show right here is when I created this value called this object LMOut as a function of this module LM here. The one thing I wanted to show you is R kind of uses these lists a lot for some of this functions and things like that. And in this case, the class though is LM. It's a special type of, it's either S3 or S4 class. So that's just real quick: vectors, matrices, data frames, and lists. Missing values. I showed you that earlier. Just to walk through demos real quick, you can see where I've got this one missing value. If I want to return the integer, that's the missing value. I just ran through there. So you can see n, and I print n. Number 4 is the missing value. That's there. If I pull the ones that aren't missing, I print v. You can see 1 through 3. Right? Like I said, if I wanted to create a new copy of that vector that just had the values that weren't missing, I can represent it this way. So look at x. This is the vector I want, bracket, and then all it's doing inside this vector is returning every position that's not in A. One of the cool things, one of the things you might want to do is that if you wanted to get the mean of values in a vector, you got some NAs, you can't do that because you don't know what NA is. And so one of the things you can do is you can use this little which is an A to set value. So in this case, what I did is I said, go and take every value in X that's missing. That's what this is doing, and set it to the mean of that vector based upon the values that aren't missing. So basically, it's the mean of these 3 values here is what's going to be set for 4. So that's the one that's missing. And you see down here, the mean of those numbers is 2.3. And so position 4 got set to 2.3. In data science statistics terms, we call it imputing missing values. So in this case, I said take the missing value and impute it to be the mean of the values that make up that. Package management, library, like that. You can see now it shows me all the R packages that are installed in my environment. That also matches what you see here. You want to load a package. So in this case, I have the ggplot package, which I don't have installed. So I can go install that real quick. There, click install. See now where it goes and downloads it and installs it. Also, if you notice, it's not just installing ggplot2, it's getting all the dependencies. So you can see these dependent packages automatically for me, installing those. As soon as that's done, here in a second. I can show you that. And so here's using ggplot, how to load a library. I won't go through these comparisons too much. I'm just going to click through them. But this is what I showed you in the slide. So you can kind of, on your own, because we're kind of running low on time, kind of walk through these logical operators and see them, but they're here. Same with control flows. These are all that are in the slide. So you can see right here for I and 1 through 10, I print it. You can see where it's printing out those values. I go with that data frame, want to print the contents of the data frame. So I want to go through these while loops. So in R, one thing I haven't talked about in the slides is functions. So R is a function-based language. You can create functions. So in this case, I'm creating a function called bonus. And all it's doing is basically taking whatever you pass into the function as a salary, multiplying it by 0.5, and then returning that value. So I create the function bonus. Then I can if I want to apply this function to my data frame, I'm going to create a copy of my original data frame called bonus. I can then say, okay, take this salary of that data frame bone and then apply this function. It's the same thing I did earlier, whereas I just did the multiplication by 0.05. In this case, I'm just showing you how you can create a function and apply that function. So then if I view that, you can see where all those bonuses are. The other thing R has is try and catches. There's some examples there. I don't have time. Usually I have a full hour, 15 minutes usually when I'm doing this session. There's a bunch of other stuff down there. One of the things I mentioned in the list is I created a data set here where I'm calculating the final grades for people, and I show you like 10 ways to do it. One of them is taking a list and splitting it into multiple data frames and doing it. Other ways is just looping through and doing it. Other ways are using some built-in packages. That's all right there for you to look at. This is second RODBC. If you want to see example of RODBC, that's there. Also, finally, I have right here is, if you remember those R client libraries I talked about earlier, this is some examples of how if I have data stored in SQL Server and I want to get that data out of SQL Server using the R client, this is an example of how to do that. So you don't have to use RODBC. You can use these R client libraries and they're a lot faster. And then there's some examples to do that. And then there's just some fun stuff at the end there. So let me get back to the slides. I just want to go real quick. So where does Microsoft have R investments? And investments are in their products. Azure ML. So if you do Azure Machine Learning out in the cloud, which is a drop environment in the Azure space where you can take data science type projects, they have an execute R script functions in there, and you can takes this in this pipe. It takes the data that's coming into this pipe, creates this variable called data set from an input port. I can take that data set one, do something to it, and then I can output it on this other end there. So Microsoft R Server, Microsoft has R built into SQL Server 2016, and here's the information on install it. It's also built in 2017. Including Python now, but the heart of it is this XP execute external script, and what it does is what it does is use this package to execute this R code. I want to show you real quick because I know I have to hurry here. I apologize for the technical difficulty with audio. We lost some time there earlier. What I have out there is this RStudio example. When you go to my download for my webpage, a database called Intro to R, and what it'll do is walk through using this XP or external script to execute. If you start playing with this and have questions, I know we ran out of time, I apologize, just hit me up on Twitter or something and I can help you. One of the things you have to do is if this is the first time you're trying to execute R in your Microsoft SQL Server and you haven't enabled external script, you have to do these commands, and I haven't commented out in that SQL script when you download it. You just have to make sure you've installed the R services in your SQL Server and you can run these scripts. So really what this does is an example of Microsoft gave. Reads in some data from an example data set called Iris, and R creates a little Bayesian classification model, Bayes, and then saves that model out to a var binary file, and then it's able to then read that model back in and apply that model to data. thing you'll have to do is install this package called E1071. This is how you do it. So this path right here is for SQL Server 2017. If you're 2016, you'll probably say MS SQL 13 or whatever you use if you change what that looks like. Sorry I ran out of time. If you try to play with this and you get stuck, just hit me up on Twitter and I'll help you out. Finally, last thing was just Power BI. Microsoft has got a built-in Power BI. You can download this Power BI sample, and all I did was read in some of the MT car data set and created a box plot. All it is you use this little R script visual, you drop it in there, and it allows you to create R script visual. Real quick, and then I'll only have time for a few minutes of questions. Here's some resources. Download that. This right here is our bloggers. I highly recommend signing up for their daily email. It's phenomenal. UCLA has a great site. This Quick R is a good site. The best person to follow is Hadley Wickham here. I mean, he has like R data science. I think the whole book actually is available on his website. You can buy it. I think you can see it on his website. I mean, if you want like to take some Microsoft Academy, they have some good. With that, I'll open it up with questions for a few minutes. Thank you for coming. I hopefully found it helpful. Apologize for the audio issues. Like we said earlier, we actually spoke for 20 minutes before we even started, and there were no issues. So don't know what happened.
Yeah, we had some issues. We're gonna try and clean up the webinar, so give us some time before we post it, and hopefully we'll get the audio maybe better so everyone can hear the gaps, because it's kind of weird.
Yeah, I don't know. Like I said, I don't know if it was something to do with the system once everybody got on, because like I know you and I were talking for 20, 25 minutes before we even started, and we never had one hiccup.
Yeah, I mean, and that's just to let everybody know, we typically open the webinars for the speakers to work out these
the other thing we
issues.
might do, we have to talk to past this. I gave this session at Summit last year, so I'm wondering if we can get a hold of that and post that. Because it's the same session, and actually I had more time, so I don't know if we can or not. But you know, we might be able to talk to them and say, hey, look, we did this same session here, and we had audio issues. So I had more time, and you know, it's a little better when you have it in person. You're not sitting at your desk giving it, and so I was able to go through demos a little better and stuff like that. And so maybe we can talk to past. And I think also I did this session. I forget where. I think somebody else also recorded it and posted it. So let me, you know, we can work to see if we can get it and get maybe get that.
Okay. Well, I want to thank everyone for attending today, and we're going to shut down at 2 p.m. And thank you, Jamey, for coming on today.
Yeah.
And
I apologize for the sound problem.
Yeah. I hope everybody has a great evening, and I look forward to seeing y'all next month. Bye.